When the supports are not in perfect condition, either perfectly machined or leveled, while applying loads, there will be an initial slack in load versus deformation plots, which does not simulate the actual member behavior. So whatever the member is, there should be an elastic portion. That means there should be an initial straight portion up to certain limit, and later there will be a non-linearity. So in this video, we will plot load versus displacement curve with toe correction with the help of MATLAB. So I have already written the code for the same, and I will share the same repository in the description below. So you can open this repository, and then you can open load LD for toe correction. This is the code. You can directly copy the code into your MATLAB editor. I have already copied it. Yeah. So the only input which we need to give is LD raw data input. So I'll copy this, and so to show this procedure, I already have a load versus displacement, which is taken from the CTM, the compression testing machine. So these are the raw load versus displacement values. I will copy all the data file into this matrix, which is LD raw data. So now we have raw load versus displacement values in the form of matrix. So the rest of the part, I will copy this and then paste and then run the analysis. So yeah, so we get the graph. So you can see this dotted plot is the raw data, and if you can see here, there is an initial nonlinearity here. So again, this is because of, like I said, there should be an elastic portion, or there should be an initial elastic, initial linear portion. So this is because of, again, the supports not being so perfectly machined or not perfectly leveled. So you can see this initial nonlinear portion or initial slack, which we have corrected it and made it the linear portion, and then you can see the corrected load versus displacement plot over here. Yeah, coming back to the coming back yeah coming back to the MATLAB code. So again, if you see n is equal to 25, again this is a parameter. The raw data file contains of about 2600 cross 2 matrix, which is again too heavy and too more in number, so we don't require those many points. So just I am defining a parameter n, so that I will pick only each point after 25 intervals. So this is you can customize this according to your application, and then uh, yeah, after this it is pretty self-explanatory. You can see each line is self-explanatory, and uh, coming to the next step, which is an important step. You can see here calculation of stiffness. So the initial straight portion is calculated with respect to the maximum stiffness. So yeah, this step calculates the maximum stiffness, and then we'll plot the corrected load versus displacement plot. Yeah, this is how the plot looks like after the correction. Thank you.